thank you, Yukako. Thank you for having me here. Can you hear me?
Yes, perfect.
Okay, thank you. Dear first members and dear guys from cybersecurity community in Asia Pacific region, ladies and gentlemen, good morning. I'm from Eversec Technology, which is an innovative cybersecurity company. It's a great honor to join this training session through this Zoom meeting. Today's topic is attack hunting with threat intelligence of DNS. I'm going to share with you guys some attack hunting techniques related to the DNS, either exploiting DNS logs or CTI extracted from them, or both. I hope you can have inspiration through my 30 minutes talk. Okay, let's begin. This training class can be divided into 4 parts. First, I want to make a brief introduction of some background knowledge about DNS and CTI. Then separate attacks related to DNS will be introduced. Third, I want to discuss some methods and solution aiming at attack hunting with DNS. Finally, I want to show some products of Eversec dealing with cyber attack in a short time. I think threat hunting is a popular buzzword in cybersecurity community. So what does that mean? Many people have different notions about threat hunting. This definition I approve for the most, which is to proactively search for malware or attacks that are lurking in your network. There is one point I want to emphasize, that the attack or threat has been there for some time. Especially in APT context, attack hunting usually assumes that attacks already happened. Although some security solution can detect attacks, it's a serious question how to stop attackers from staying there. So we can classify attack hunting into 3 types. The first is hunt for attacks within your organization. Hunt for a threat proactively on the internet is the second type. And the third is hunt for attack with a trap. Compared to the previous, each category has lower demands in market volume, but needs more advanced toolkits and skills. So what does DNS means? DNS stands for Domain Name System, and it is a mechanism to make the internet a more human-friendly place. Now we can make a demonstration of resolving domain name here. For example, if we type www.google.com on your browser, if the DNS records are located in your computer's DNS cache, you'll be taken straight to the google.com to avoid the remainder of your DNS request. If no data is detected, a query will be forwarded to your local DNS server. If the data on the resolving name server are not cached, then the request to find the DNS record is forwarded to a root name server. So when the DNS records are found, a link is opened to the server where the site is stored and google.com is seen on the computer. Well, apparently, we can infer from the process that DNS is built on the principle of good and loosened. Considering some risk of mid-party attack or say fraud, professionals on internet and propose the encryption and authentication solution for DNS, such that DNS over HTTPS, DOH, and DNS over TLS, DOT were introduced. DOH uses HTTPS port 443, which is normal in internet perspective. But DOT uses 853, which may be blocked by firewall. Encrypted DNS is a kind of mixed blessing. For convenience consideration, DNS over TCP or UDP port 53 or say DO53 have some risks. Those include easy for companies to monitoring, easy monetize for ISPs. And encrypted DNS has some risks, including encrypted DNS will be resolved with DO53. at somewhere upstreams, which is convenient for the cert members to hunt for villainies. And encrypted DNS can protect your privacy by encrypting your serving trace. As for secure concerns, DO53 is easy for DNS channel inspection and easy for DNS logs extraction. Well, DOH or DOT is hard to decrypt it, except for the interception with certification. It can also prevent our systems from reconnaissance and mitigate DNS spoofing. Well, nowadays, red team or blue team is exploiting cyber threat intelligence, CTI, as a weapon. CTI plays a key role in attack hunting related to DNS as well. DNS CTI could be defined as all the threat information that comes from the DNS and interaction of its users. DNS serves as early warning and detection solution for phishing, spam, malicious, and suspicious behavior, and other attacks. DNS intelligence is considered the only source of ground truth information for the internet. So we can get CTI of DNS from source of commercial provider like Infobox, Farsight, SOC, Literator, or organizations, non-profits like Whois provider from all over the world. DNS CTI includes darknet, spawn select, phishing URL, etc. So given a query, we can profile of a DNS with CTI. So there are some examples listed below. We have many information extracted from logging directly, such as associated IPs for DNS records, DNS historical records, reverse DNS record, and register name servers, blue record history, etc. Some intelligence is extended from DNS itself, like DNS software identification for associated domain names. Both DNS logins and CTI play important roles in attack hunting. DNS query logging is effective to detect hostname lookups for knowing malicious domain. We can collect DNS logs from DNS server, DNS client, DPI, DNS sniffer, and so on. For example, ZIG sensor to TCP UDP port 53 to collect DNS stream. DNS cache is a good short-term investigative tool for attack hunting. We can depict the process of gathering DNS and other information in the network topology graph, like I showed above. DPI is a powerful tool of DNS logging extraction. Different data is transferred into SIEM to help enhance attack hunting ability. Next, I want to show you different kinds of attacks related to DNS. All right, let's begin with DGA subdomain enumeration. It's to find subdomains for one or more domains. There are two types called active domain enumeration and passive one. So what is passive subdomain enumeration? It is performed by using publicly available data, such as search engine results, querying DNS records on DNS servers, and so on. This data is typically collected automatically, and no interaction is required with the target domain. Like VirusTotal is a famous CTI examining tools online. It performs as passive DNS enumeration. Active subdomain enumeration is performed by interacting with target domain, such as through web requests, DNS queries, and so on. This data is typically collected manually, and some level interaction is required with the target domain. So one of the best known subdomain enumeration tool freely available is OWASP MS. It uses variety of techniques such as search engine harvesting, DNS enumeration, brute force attacks, and more. DGA is a specific algorithm used in malware to generate domain names in batches. Hackers use seed, which is an input of the attack in DGA. In order to control the process and result of the DGA, DGA includes arithmetic-based, hash-based, dictionary-based, and permutation-based methods. DGA is usually used as a tool to make botnet hidden. Domain flux protocol is proposed, of which algorithm is DGA, while C2 domain name is generated by a certain algorithm. Mid-nodes between attackers and the compromised host are changing, which could evade C2 detections. DGA identification based on DNS is required for botnet event hunting. DGA tunnel. DGA tunnel is due for C2. It transmits information through the DNS protocol. DNS tunnel inserts an additional string of data into the pathway. It establishes a form of communication that bypasses most filters, firewalls, and packet capture software. DNS hidden tunnel, or we say covert channel, has two types. We name when red teams deploy DNS servers as domain name based method. When red teams deploy UDP tunneling, turning software to inject data into the spare space at the end of an existing DNS message, we name it as server-based. DNS hijacking, also named DNS redirection, is a type of DNS attack in which DNS queries are incorrectly resolved in order to unexpectedly redirect users to malicious sites. Let's take external name server attack, for example. Attackers can compromise a domain registrar account and modify your DNS name server to one that they control. Furthermore, hackers can compromise an organization's router and change the DNS server that gets pushed down to each device automatically when users sign on your network. This is another little bit confusing notion. DNS poisoning can also call DNS spoofing. The trick is to redirect internet traffic to malicious websites. DNS poisoning happens when a hacker intervenes in that process and supplies the wrong answer. Once it has tricked the browser into thinking that it receives the right answer to its query, the hacker can divert traffic to whatever fake website it wants. We should keep in mind the trivial difference between DNS poisoning and the DNS hijacking. DNS hijacking emphasizes that the DNS server is compromised and manipulated by intruder, while DNS poisoning means hacker modified DNS result to deceive an end user. Well, based on the discussion we just made, we have listed DGA related to C2, subdomain enumeration, DNS tunneling, DNS hijacking, and DNS poisoning. I think they are a little bit dispersing. Well, next I'm gonna show you how to mitigate those attacks respectively. DNS CTI is used as tracking or tackling or the DNS-related attack hunting with CTI is discussed here. And I just said, when we say attack hunting, we make an assumption that bad guys are already inside and he's already on the way. Whatever DNS hijacking and DNS poisoning at any stage on the way, but haven't accomplished their goal yet. CTI is integrated in hunting. Let's take a look at this graph, considering Q chain model. Attacks usually initialized in a way of advanced persistent threat, APT, on the lower quadrant. DNS fraud can be used as a tool at any stage like reconnaissance, weaponization, exploitation, installation, or whatever. For example, it can be conceived as a covert channel in C2, command and control. In this context, DNS CTI is data source of AI and UBA to hunt evidence of attackers. Well, in most cases, CTI is utilized by both parties of confrontation between red team and blue team. It's an adversarial process. So if your SIEM or SOAR warning logs and then sniffing some clue about the attack integrated with CTI, like which organization the attacker may belong to, is that a phishing URL, or is that from a location where suspected APT appears? And then you are gonna say, bingo, that's awesome, I made it. A profile of the attackers is down. Well, it's a pity. Attack hunters is profiling the defender or cyber victims. So that's a process of a confrontation. CTI must be iterated and updated in real time. Anyway, entity profiling technique for better understanding for DNS CTI. That's essential to your SOAR and essential to attacker's weapon as well. Well, in your SOAR or SIEM, we can build an CTI Management Center like this. Except for DNS CTI, some common CTI including general purpose vulnerabilities, event type vulnerabilities, phishing database, and IOC like antivirus, signatures, and malicious IPs. Although these are enabled to detect and growing dangers from zero vulnerabilities, they are still useful in attack hunting in an early phase. A well-designed CTI management center can help you build and maintain your CTI database. The management module should cover some basic database manipulation operation, including CQ, and some advanced functions for experts in blue teams as well. And for DNS security monitoring from logging, especially, it can gather information of recursive resolution logs of domain name information security system, or say DNS logging recorded by DPI sensor. DNS information security system, if possible, it needs to be synchronized from DNS registrar. The DNS monitoring logs collect the access log data of domain name servers of operators. Through data collection like DPI or NDR, network detection and response. Using DNS security monitoring, we can make monitoring domain name hijacking, domain name solution, domain name pollution, domain name malicious domain, and DGA domain names, and other domain name security events. Well, according to my experience in blue team where hunts attack, CTI distillation from DNS logs is a real-time work of DNS CTI gathering through open community. Using big data security, we gather data including apps, communication logs, malware, and Trojan, etc. And some events, security events, etc. From cybersecurity devices like next generation firewall, intrusion detection systems, network detection and response, web proxy, and something like that. And then transfer data to ETL and to UEBA sandbox, covert channel detection module, scripting threat detection, and something like that. Then we form a theme with big data and artificial intelligence, with cyber threat detection, with DPI and DNS as data input. Now let's take some DNS-related attack hunting cases, for example. We have many DNS subdomain enumeration detection methods in an early stage. Their models are proposed based on DNS CTI or extended data record in form of something like that. For DNS subdomain blasting attacks, by detecting the request packets and the response packets of DNS log, it can be judged whether there is a subdomain blasting attack. Beacon analysis is used during abnormal DNS datagram identification. So as a typical cyber threat about DNS, as I mentioned in previous section, we consider a so-called expertise system to hidden DNS tunnel. From the original DNS traffic, NDR is used to gather extended data records, combined with UDP payload, content analysis, and tunnel program identification. In real-world DNS tunnel detection, if we have enough experts staff in analysis, the recall rate will be raised. But I think to establish expert system can reduce your cost. So DNS traffic analysis, UDP payloads analysis, and the tunneling software recognition are combined to make a decision whether there exists a DNS tunnel. Several kinds of feature data, including DNS data packet characteristics, message features, and the connection statics, are extracted from the combined expert system. The output of a machine learning classifier is whether it is a DNS covered channel or not. Or maybe we can use a regression model to output the confidence of the probability. So in DNS hijacking hunting scenario, in my option, it is a necessary process. DNS hijacking is one of the most devastating weapons to internet. We need to take measures to analyze, detect, and even predict DNS-based threats before they happen. Build DNS CTI database is necessary. We take 3 steps to build an ultimate DNS hijacking CTI database. We should confirm the accuracy of hijacked DNS labeling. I think it takes automation to beat automated attacks, while applying the DNS candidates intelligence in order to even predict DNS hijacking related behavior before happening. Some traditional security devices like EDR or IDS are used to make some basic security checks to make warning of DNS hijacking. Well, the following example demonstrates a DNS cache poisoning attack in which an attacker intercepts a communication channel between a client and a server computer belonging to the website www.esource.com. In this scenario, a tool is used to dupe the client into thinking that the server IP is 192.168.3.300. At the same time, the server is made to think that the client's IP is also like that. Considering the time limited, if you are interested in it, just read the process in detail. So threat hunting with DGA detection. When the domain name meets the following two criteria at the same time, we may judge it as a suspected malicious domain name. First, domain name is unreachable. Second, the domain name hasn't been registered on the website. It seems very simple, but we designed the procedure elaborately. Threat hunting with DGA detection procedure can be summarized as below, like the architecture to the right. So first, we extract the complete, the thorough DNS access record from the traffic. Second, relying on knowledge such as black and white list, domain names, and the black and white IP address list. Feature extraction rules are used to achieve feature extraction of 6 dimensions. Finally, we can identify the malicious domain name through the training of neural network in-depth learning feature module. Okay, time is up. Okay, advertisement time. Don't change your channel. I promise that will be short but fascinating. Science and technology engineering company to describe Eversec. We want to build a protection system based on focusing on telecommunication security. Our solution and the products includes comprehensive protection of cybersecurity and smart big data analysis of network. We provide service and operation as well, includes operation and maintenance services. This is a graph of the products of Eversec. We are doing research and design in artificial intelligence and network security to make some novelty about the cybersecurity community. Our products include malicious program detection, malicious domain name detection, traffic detection, botnet detection, smart intelligence detection, and the most important, APT detection. Another leading product is focusing on knowledge application and insight analysis. Let's take an example of this process. We build this product based on knowledge graph. Our product can build a data modeling chain from data to knowledge graph and then to industry application. We can make malicious organization profiling through this tool to keep cyberspace safe. So that's all I have covered on this topic. Thank you. Thank you.
Well, thank you very much, Pengchao, for the great presentation. We have a couple more minutes for the questions from the audience. Is there any question from the audience? You can basically type into the Q&A box. Any questions from the audience? Okay, I see one question from Lawrence in the chat box. So do you see DGA still active in recent cyber attack trend? So can you answer that, Pengchao?
Of course. According to our experience in Blue Team, in a real world confrontation between attacker and defender, most of the botnets, most of the command and control nodes have some labeling or has the domain name of DGA, according to our experience on daily monitoring. And maybe in our last month's report on cybersecurity, I mentioned attention should be paid that about 80% 80% of command and control nodes are labeled as the DGA domain names. That's as far as we know. Am I clear?
Well, yeah, I think so. So thank you very much for your answer based on your observation. Yeah, in
Okay.
Lawrence's. So yeah, thank you very much for that, Pengchao. So I think that's the end of the session, second session. Thank you very much again, Pengchao, for the presentation.